Okay, so Assalamualaikum and salam sejahtera. Okay, alright, so this is our virtual class. Okay, even though it's a not live session, but yeah, I hope that this feel like a live session. Okay, so I have a reason why I do this pre-record instead of live because of based on the previous semester, so some of my students cannot attend the live session. Okay, I mean they have difficulties on they have a problem regarding the connection and so on lah. Okay, so it doesn't matter whether this is synchronized or asynchronized, is it live or not, but as long as I deliver, and I hope that you can get lah what I delivered for you. Okay, alright, so I received many DMs, many questions regarding matrices, question regarding determinant specifically. So I come up with this video to explain or to teach. I mean, you can imagine that I teach you in front of you in the class. Okay, instead of using the whiteboard, I use a piece of a A4 papers. Okay, so I hope that this video will help you a lot. I mean, not I hope that this video can help you lah. Okay, saya harap walaupun tak seberapa, tapi hope that video can help you a lot to understanding the topic. Alright. Okay, so we will start the matrices. Okay, before we go to the determinant, apa-apalah semua tu, the first thing first that you need to know for the matrices is the sizes of the matrix itself. Okay, the size. Okay, the sizes. So matrices are classified by the number of rows and columns, right? Okay, number of columns. So let's say you have a matrix A here. So 1, 2, 3, 4, for example. So what's the sizes of this matrix? Okay, the sizes of this matrix is represented by rows and column. So it must start with row and then column. Okay, row, column. This is column, this is row. Okay, so the sizes is 2 by 2. Okay, the first number here is represent row, the second number here is represent column. So you can see the matrix A here, they have 2 rows. Okay, so that's why it's 2, and it have 2 column. Okay, so the sizes of this matrix A is 2 by 2 matrix. Okay, for 3 by 3 matrix, you have something like this lah. So you have 3 rows and you have 3 columns. Okay, and then you also can have a matrix something like this. So this is a 1, 2, 3, 3 rows, they have 2 columns. So the sizes of the matrices is 3 by 2. Okay, alright, so this is about the sizes. Okay, so now we will go to the types of the matrix that we have. I mean the types of matrix that you should know lah, you should know. Okay, so first of all, okay, because of some of you ask what is this matrix, okay, so I start with the square matrix first. Okay, what is square matrix? Okay, square, okay, what you can imagine when I say square, the shape of square must be equal, right? Dia punya sisi semua sama. So same thing for the matrix. Square matrix means the sizes. Okay, before that, okay, 2 times 2, 3, 3, and so on. Okay, the first row, the first number I said just now, the first number is represent row, the second number is represent column, right? So we use n, m. Okay, for example like n, m. Okay, so what's mean by square matrix is the sizes of the matrix is equal, row and column. Maksudnya numbers of row and number of column must be equals, so it can be get a square matrix. For example, 1, 2, 2, 3 here, so you have 2 rows, 2 columns, so it's a square matrix. You have 1, 1, 1, 0, 1, 3, 0, 1, 4. You have 3 rows, 3 columns, so it's a square matrix 3 by 3. Okay, how about the matrix C just now? This is a not square matrix. Okay, you can see that this is not a square. It's something rectangular, right? Okay, so this is not square. So that one is square matrix. Okay, so now what is identity matrix? What is the identity matrix? So identity matrix and also diagonal matrix. Okay, so diagonal matrix is the question that asks you in the ULearn. Okay, hope actually you can get the answer by referring to the slide. Okay, but okay, I just brief here. Okay, so now for the identity matrix first. So for these two matrices to be declared or to classify these two matrices identity and diagonal, it must be a square matrix. Maksudnya syarat pertama, condition pertama untuk dia adalah identity ataupun diagonal, dia adalah mesti square. Okay, square matrix. Okay, so what's mean by identity matrix? Okay, identity matrix, okay, first of all you need to know the diagonal. Okay, this one is diagonal, right? This entry is a diagonal. So others than diagonal, the entries here or the number here must be 0. Okay, that one is the first condition. Same thing for diagonal matrix. Okay, for the diagonal matrix, the others entries line diagonal. Okay, the others matrix except the diagonal must be zeros. Okay, back to identity now. Okay, so now what's the number that lies in this diagonal? The number can be here is only 1. Okay, the number that can be enter ataupun appear in this diagonal must be only 1. So that's why its name is identity matrix. So this matrix is 3 by 3. How about for 2 by 2? Okay, for 2 by 2 means just only they have 2 lah. 0, 0. This is 2 by 2 matrix. How about if 4 times 4? You have 1, 1, 1, 1. And then the rest all are zeros. Okay, so that's one is identity matrix. Now we back to the diagonal matrix. So for the diagonal matrix, what's the number that must lies here? Kalau tadi identity, it must be only 1. And for diagonal, it can be others than that. I mean, it can be any number. It can be any number. It can be number 1, number 2, number 0 also can. Okay, so for the condition to make it diagonal matrix lies is only the what we call the numbers others than diagonal must be zeros. That's it. The diagonal itself can be any number. Okay, right? So the most important thing is the shape or the matrix must be square. So if the matrix is not square, so that's mean it's a not identity, it's not a diagonal. Okay, alright. So now we come to the transpose matrix. Okay, transpose matrix. Sorry tulisan saya cakap ayam sikit because I want to make it this video short. Okay, alright. So what's mean by transpose? Okay, transpose is you interchange the row and the column. You interchange row become column and row become column. For example, you have a matrix A. Okay, so what's mean by A transpose is, okay, this is your row. Okay, this is your row 2, 1, 0. So now instead of row, now it's become column here 2, 1, 0. So means row number 1 will be column number 1. Row number 2 will be column number 2. Row number 3 will be column number 3. And for transpose matrix, it's not, I mean, it can cater for all sizes. It's not only for square matrix. It can be any size. Okay, let's say you have a B here, 1, 2, 9, 8, 7, 6. Okay, this sizes is 3 times 2, right? It's not a square matrix. So you still can have a transpose of B. So it become, okay, so now a row will become column, right? So it can 1, 2, 9, 8, 7, 8. 7, 6. So this is how we do a transpose of a matrix. Okay. Okay, so last before we end this video. So let's say you have a question like this. The question asks you to prove or to show A transpose transpose. So for this one, you will get back the original matrix. Why? Because of, okay, you are the original matrix. After that, you transpose it. You dah tukar jadi row, column and so on. And then after that, you change again. Maksudnya daripada row, you jadi column. So now you will become, you will do the next change, row become row. So you will get back the original matrix. Okay, alright. Okay, so for the next video, I will explain on how the operation of the matrix, addition, subtraction, multiplication, and so on. Okay, alright.